Okay, so here's a question to think about. Can an object have a constant velocity but a changing speed? Yes, no, or depends? Well, if you think about it, for the velocity to remain constant, remember velocity is a vector. So a vector contains a magnitude and a direction. And the magnitude of the velocity vector is the speed. So for the velocity vector to remain constant, the speed must also remain constant because that's the magnitude. You cannot change the magnitude of a vector and claim the vector is the same. So no, it is not possible for an object to have a constant velocity but a changing speed. Think about it the other way. Can an object have a constant speed but a changing velocity? Now again, your answer choices are yes, no, or it depends. Now in this case, remember the speed is just the magnitude of the velocity vector. So another way to say this is, can an object have a constant magnitude of its velocity, but the velocity changes? That's kind of like saying, can a vector have a have its magnitude change, but the vector itself, can the magnitude stay the same, a constant magnitude, but the vector still is considered to have changed? Can that happen? It can happen because you can change direction, okay? So if you're driving and you're in cruise control, you'll be moving with a constant speed, but if you turn your steering wheel, you're changing your direction. Therefore, you have changed your velocity. Remember, velocity is your speed and your direction. That's what velocity is because it's a vector. If you change your direction, your velocity has changed, even if your speed is constant. So you can be in cruise control and turn your steering wheel. Your velocity will change in that case. Now that brings us to acceleration, because we have defined acceleration as a change in velocity. It's the rate of change of velocity. So let's talk back about a car. What part or parts of a car can cause it to accelerate? Think about that for a second. Most people, when they think, if you just go out on the street and ask somebody, what can you do in your car? What part of your car causes it to accelerate? Most people would say the gas pedal, because most people think accelerate means going faster. Now in this class, we've said acceleration is when your velocity changes. So I hope at least you would also say the brake pedal now that you're a physics student, right? Because we would say when you press on the brake, you're still accelerating. You're just accelerating in the opposite direction that you're moving, right? So this is kind of what we would say based on what we learned in week 2 of the class. And now we can even add a third thing in the car that causes it to accelerate, according to a physicist, and that is a steering wheel. Okay? According to physics, the steering wheel causes a car to accelerate because it changes the velocity of the car, because it changes the direction the car is moving. And velocity includes both the speed and the direction. Anytime the direction changes, the velocity has changed. Therefore, the car has accelerated. Now, I want you to watch this part of the video again because that's really an important concept. Anytime the direction of the object changes, its velocity has changed, which means it has accelerated. Okay, so any change in speed means a change in velocity, or any change in direction means there's a change in the velocity. That means that any change in speed and or direction means there is an acceleration. Okay? This is our definition of acceleration from before. The only thing that's new is I put little arrows to indicate that acceleration is a vector and velocity is a vector. Let's go back to these old pictures. Okay? In this case, this object is speeding up. What's the direction of the acceleration? Well, when you speed up, your acceleration is in the same direction as your velocity. This object is slowing down. What's the direction of its acceleration? It's opposite the direction of velocity because it's slowing down. Now let's consider an object where the speed is constant. It's not slowing down and it's not speeding up because the length of this velocity vector is the same as the length of this velocity vector. So The speed is the same, but the direction has changed. This object is turning. When I think about what is the direction of velocity, there can be no velocity in this kind of up and to the right direction. Because if there was, no acceleration. If there was any acceleration up like this, then the object would speed up. If there was any acceleration down like this, the object would slow down. So I cannot have an acceleration in this direction or this direction. I cannot have any acceleration along this direction. The only acceleration that makes sense here is something that's perpendicular to my velocity. So that when you have an acceleration that's perpendicular to the velocity, that makes your velocity just so that you turn, but you have the same speed. Any part of your acceleration that's in the same direction as your velocity causes you to speed up. Any part of your acceleration that is negative in the opposite direction of your velocity causes you to slow down. And any acceleration that's perpendicular to your velocity causes you to turn.